So now we are going to present 𝘂𝘱𝘁𝗂𝗂𝘁𝗲. I think maybe you jump on stage a bit early. But Kevin, yeah, over to you for the presentation of UQModel, so uncertainty quantification. So Kevin, you are a research engineer at IRT Systemics, and I will let you present them.
So hello everyone, my name is 𝘂𝘱𝘁𝗂𝗂𝘁𝗲, and I'm here to present UQModel for time series, a Python library that try to enhance AI confidence with uncertainty quantification. So UQModel have some target some industrial problem related to predictive maintenance, system monitoring, or anomaly detection on complex system. To tackle this kind of problem, we have to face some issue related to the fact that there is numerous different use cases and in-house problem with a lot of specificity and constraints. There is also a need to integrate a lot of expert knowledge in data science pipeline in order to have relevant results. So the industrial needs some pipeline and tools to facilitate model conception, benchmark, and evaluation. And these tools have to be compatible with real applicative constraints and have to be able to integrate the expert knowledge. And the industrial also want to control and to make certification to ensure AI system confidence. And on several dimensions of trustworthy attributes as uncertainty mitigation, which is one of the purpose of UQModel. So from this state of industrial need, we can extrapolate some design requirements which have been used as base of UQModel implementation, like it is relevant to have modular pipeline builder. Industrial want to take tools which can help to make trust and risk mitigation, like UQModel try to integrate some uncertainty quantification mechanism, and industrial wants tool which can facilitate model conception, like UQModel, which provides some complex deep learning model in order to make uncertainty quantification. So we try to respond to a big question: how to ensure AI component confidence of system facing several sources of uncertainty. So company, industry, or public services can collect massive, complex, and context-dependent data. Such data are impacted by numerous sources of uncertainty like noise, bias, sensor imprecision, observation-like. And these data are used to feed AI components that can perform, for example, forecast, monitoring, or decision-making tasks, which means this AI component will learn on noisy data and can have some misrepresentativeness issue. AI components do not necessarily incorporate domain expertise, so that means they lack of knowledge and then can have a noise sensitivity. And AI components do not necessarily handle the impact of uncertainty, which means they literally ignore some risk. So if we want to use their output, their decision, how can we face the risk related to misuse, to misunderstanding, to low precision, or to irrelevance of AI component output? So that here that uncertainty quantification can help a bit by advice to provide some complementary indicator that can characterize model outputs on several dimensions, like on the dimension of the uncertainty of the output by providing some information like margin of error or interval of confidence, but also about output reliability that provide information about the real ability of a model to face an input. So UQModel for time series is ensured in ML uncertainty quantification field, which aims to mitigate the impact of source of uncertainty on AI models. There is several ways to do that. We can, for example, try to formalize ML task with uncertainty. For example, we can make classification with unknown class. We can also try to make model calibration in order to hold gap between training and application data. That's the purpose, for example, of conformal prediction tools. We can also invest some effort into the production of refined evaluation in order to go beyond average error, for example, including risk aversion in operational metric. UQModels is more ensured in the fourth way, produce complementary indicators that provide information and that help to characterize the relevance of the model output. So UQModel is linked to a subfile of uncertainty quantification, which is uncertainty quantification by design, which try to produce a model that can perform a task and that can also perform uncertainty quantification. Such subfield can provide some very interesting outputs, like uncertainty indicators that can be held, that can be used as data characterization in data analysis steps, for example, in order to better understand data. It can also provide some model with uncertainty quantification, which can be very relevant in model conception phase in order to provide trustworthy model decision design. And it can also provide uncertainty indicators that can characterize model outputs, which can be very relevant in operation application, for example, for risk-aware decision or monitoring purpose. So in a data science life cycle, UQModel, which is a Python library which provides some functionality, which be mainly involved in AI conception and learning phase, and also in post-processing and calibration phase, by learn model and UQ estimator for time series, and by set up post-processor for building 𝘂𝘱𝗁𝗂𝗃 upon the output of the model and upon the output, the uncertainty estimation of UQ estimator. This 𝘂𝘱𝗂𝗃 can then be used in operational application. For example, we can use prevision complemented with uncertainty indicator, which can be provided to operator in charge of monitoring in charge of the monitoring of some industrial system. Also, we can integrate this uncertainty indicator into some anomaly detection functionality. There is a direct perspective to valorize such uncertainty indicator to provide some AI operation capability for monitoring purpose. So let's summarize quickly what is UQModel. So UQModel is an open source Python library built by 𝘂𝘀𝘱𝗁𝗂𝗃𝗃𝗃. His goal is to facilitate ML prototyping and benchmark of model with uncertainty quantification for time series analysis using a scikit-learn API. The main functionality are to provide model with uncertainty quantification for forecast and anomaly detection task on multivariate time series. There is a small text specificity, which is to try to produce aleatoric and epistemic uncertainty indicator based on disentangled uncertainty quantification. In the Confiance AI end-to-end methodology, it will mainly be involved in conception and implementation phase. So ML algorithm engineer could use UQModel for ML conception and evaluation purpose, but also for prototyping some ML pipelines that will perform end-to-end application of anomaly detection considering uncertainty. And as said before, it can the indicator produced by UQModel can then be used for provision task or for anomaly detection for data and model real-time monitoring. So a quick dive about what is provided by UQModel. UQModel hold the provision with confidence interval. For example, there is ML approach like random forest with variance estimation on time representation and like feature. Or also deep learning approach like CNN, LSTM, or encoder-decoder structure, which respond to a probabilistic regression task using Gaussian negative log likelihood loss. UQModel also provide anomaly detection with dynamic threshold on multivariate time series. The idea is to build anomaly score based on multivariate score, which shows deviation normalized by uncertainty. The main idea is your data can face heteroscedasticity, so then it can have some location where there is very lot of variability, and in this location, a big deviation is not synonym of anomaly. At contrario, in some location of your data, you can have a very small variability, and in such context, even a small deviation can be very significant and can be the signal of anomaly of or maintenance predictive issue. Plus the technical functionality, UQModel tries also to propose agnostic and modular integration using wrapper or encapsulation process for end-to-end application. The idea is to consider that data are often raw, and to tackle this data, you have a step of processing, you have a step of task formalization in order to say what your AI system have to do. You have the main step of modelization and KPI post-processor, where UQ by design and post-processor are involved. And then you can have also a step of evaluation, where we want to evaluate the main output, the decision, but also the complementary indicator of uncertainty to assess if the uncertainty estimation is relevant. So, quick illustration of the usage of UQModel with some code. So here I show how you can apply UQModel in order to make forecast with confidence interval and also anomaly detection on multivariate time series. So here it's a three-dimensional multivariate series, but I only display two of the three dimensions. So the first block is the preprocessing part, where we make data loading and data preprocessing in order to build the initial representation. Then we can, in 2 lines, specify which UQ model by design we want to use. For example, here there is an instantiation of a random forest with uncertainty quantification model, or the instantiation of an LSTM, which make LSTM encoder decoder, which make multi-horizon prediction with uncertainty. Then we have to specify which post-processing related to the uncertainty indicator that we want to obtain after the prediction. For example, here we can instantiate a confidence interval post-processor, an epistemic score post-processor, and an anomaly score post-processor. Then we will encapsulate all this stuff into an object which is called UQModel, and we can only make UQModel fit in order to fit all this stuff. And then we can use the predict method in order to forecast and to obtain uncertainty indicator like confidence interval and reliability score. And we can use the method score in order to produce an anomaly scoring. Here, for example, you have an illustration of the forecast with confidence interval, of an anomaly detection, and of the anomaly score related to the ground truth. And you can see that there is a direct correlation between the anomaly score and the ground truth. So to conclude, some other examples which have been used UQModel in order to perform some interesting tasks. The first one was work done in @𝗀𝘀𝘀𝗂𝘀𝗀, where we try to make end-to-end application of unsupervised anomaly detection on multivariate time series. There is 16 dimensions. It's data from a sensor engine. And here we apply 3 steps pipeline, where from raw data we first build usable representation by making, for example, moving average representation. Then we apply the core of UQModel. We have to make a nominal modelization in order to provide forecast and uncertainty indicator, uncertainty aleatoric and epistemic indicator, and then the anomaly score post-processing, which valorize the UQModel output in order to produce anomaly score. We have also in the corner an illustration of the epistemic score utilization. So here on another use case, which is gas prediction, we set up a model in order to make forecasting with confidence interval, but we also have an indicator that informs us about the reliability of the model prediction. And if we if we apply the model which have learned on a specific distribution on a new sample which does not belong to such distribution, the model can express that he is irrelevant to face such data. So it can provide a prediction and interval de confiance, but it also provides an indicator that say, do not trust what I said because the data does not belong to my distribution. And finally, another illustration of multivariate anomaly detection where you can see that we can obtain such interpretability using the multi-dimensional anomaly score to track the specific anomaly pattern on complex and multivariate time series. Thanks for...
Thank you, Kevin, for the presentation.
Yeah.
I don't know if